All right, we're going to finish up with some real-world applications of domain and range. First, we have a homecoming dance table here with tickets and prices. You can think of the tickets like your X and the prices like your Y, because we'll always put input on the left, output on the right. So the domain, we're not going to write out all the numbers, we're going to represent it as a phrase, is the tickets, and the range is the price you pay. So why do the domain range have to be 0 or positive values for this problem? Think about that in a real world scenario. You cannot have negative tickets because 0 or positive would just mean it can't be negative. And make sure to say it for both because they asked about domain and range. So tickets or price cannot be negative. So then if domain and range have to be 0 or positive values, express that as an inequality. So let's talk domain first. When we use inequalities, when we want to have a variable. So for tickets, our domain is X. Or you could use T, and you just need to make sure you define that T represents your tickets, P represents your price, but we're just going to use X and Y. So if X has to be 0 or positive values, that just means it has to be greater than or equal to 0. That would take out all negative possibilities. And same thing for the range, except its variable Y has to be greater than or equal to 0. If we look at gasoline usage for the next example, it's given us a graph where we have the miles driven and gallons in the tank. Always use those axis labels to help you. This is considered a continuous graph because all of the points that create this line are connected. The domain would be the x-axis, so that would be the miles driven. And the range would be the y-axis, which is gallons in the tank. Earlier we said a linear graph never ends in either direction. In this context, why can't the domain and range be all real numbers? So by earlier, we're talking about the example above. We said a graph that is a straight line continues on forever and ever, left to right and bottom to top. But that wouldn't make sense for a problem like we see here. It has to have a limit. So if you see the graph is going to end where it's at 0.15, and right now it's at 207, but this doesn't actually have to stop. So I'm going to put a dot, dot, dot here to make you see this is where we are going to start the graph at 0.15, but doesn't necessarily have to stop at 207. So let's discuss why it can't be all real numbers. If your domain is miles driven, so it can't be negative, which would have to be part of all real numbers. It has to be 0 or more. You can either drive no miles or you can drive positive miles. And then for range, we said the range is gallons in the tank. Which also cannot be negative. So at some point, the y is going to hit the x-axis. The y is going to hit the 0 axis if this line were to continue. But it wouldn't be able to go past that point because once you have 0 gallons in the tank, you just have to fill back up. You can't go to negative gallons. Doesn't make sense with a car. So the last two questions of each example here, part C, was similar. It's just you have to make sure to represent it in context. B kind of fits into that too. So that should help you finish up your 1.2. You can work on the practice and check your answer keys. I'll get these last few filled out on page 11, and then you'll be ready to try out some self-assessments on Canvas for 1.1 and 1.2.